Welcome to this presentation about myself and about our research and our contribution to the cost action fairness. I'm Lisette Klok. I'm from the University of Applied Sciences in Amsterdam, and I have a role in Working Group 3, the dissemination and application. And in our contribution and in our research, but really also in our contribution to cost, we want to focus on micrometeorological measurements to understand the problem and the effective measures related to heat in cities. About myself, well, I'm a researcher, lecturer for almost 10 years now in urban climate adaptation at the University of Applied Sciences in Amsterdam. I'm actually expert in urban heat and focus on research questions like how can cities adapt to heat, what are effective adaptation measures, and suitable heat design guidelines. Before I became active in urban climate, I did a PhD in glaciology and climate research at Utrecht University, and I did my master's in meteorology, or well, in soil, water and atmosphere at the Wageningen University. Well, about our research. I'm in a big group of researchers and lecturers on climate adaptation. This is and in this group we work on the heat resilient city. The research we are doing at our university is applied research, which means no fundamental research. The research we're doing is really for the practical world, for the urban designers, the urban professionals at local authorities, at water boards, etc., who need to know what is the problem of urban heat, what are effective measures, and which urban design guidelines help cities. And in these questions, micrometeorological data play a huge role. For instance, in these topics, to understand how often it becomes hot and to understand how much hotter cities are with respect to rural environments and how often we can expect tropical nights, and to understand what urban design, for instance, shading or vegetation, trees, help in making cities cool. We need micrometeorological measurements. And in this work, we actually use two types of measurements. We have the short-term measurement experiments, in which we use the Davis stations or Kestrel stations, which you see on the pictures, or eye buttons. With these measurements, we often research what the effect is of green or water on the air temperature or the thermal comfort or the perceived temperature. Next to this, we use existing measurement networks from citizen science or professional networks to, for instance, understand the urban heat island effect. I show you some example studies. Here to the left, you see the urban heat island effect of Amersfoort, which is a small town or city in the middle, in the center of the Netherlands. Here you see the nighttime urban heat island effect during the summer months. To understand, is one area, urban area, really much more warmer than the other area? But we also looked into data for the number of hot nights. So are there more tropical nights in one area than in the other? And are there more tropical nights in cities with respect to the rural environment, just to understand the problem of urban heat? We also did measurements in bedrooms because one of the problems or risks of urban heat or heat is that it reduces sleep comfort. So we investigated what are actually the air temperatures within our sleeping rooms, and does this really differ depending on what we do with the curtains or the sunscreens or opening or closing windows. For this experiment, we used very simple eye buttons. Now, these Davis and Kestrel's instruments we use to understand what effective measures are in urban design. Here to the left, you see a study in which we measured many locations in Amsterdam to understand what the cooling effect is of water, of green, grass, of shading, trees, or shading of buildings. And we investigated the cooling effect in terms of differences in air temperature and in the physiological equivalent temperature. We also used the network of the Wageningen University to understand fluctuations in the urban heat island effect in Amsterdam, to understand if locations or areas with more trees really are really cooler and substantially cooler than other locations. Just some examples. Now, the partners with whom we work are municipalities, water boards, national and local governments, citizen science, public health service, consultancies, urban design, and also the Red Cross Climate Center. So as you see, we have many partners with whom we work together to make our cities climate resilient. And I can also bring those stakeholders into contact with our action. Now, I think our contribution to fairness is generally to provide case studies, like I showed you some examples, to show how micrometeorological data can be of good use to create heat resilient cities or climate adaptive cities. And from these studies and from these studies, I can also help in specifying what the requirements are on the data. And as I said, I can involve stakeholders and urban professionals. Now, I also thought of doing a pilot study within COST to set up a case study based on the collected air temperatures that we might collect. A case study to understand the problems, or no, to understand how hot summer nights can become in cities, and actually to do more statistics on the air temperatures within cities, to understand how hot cities can become and how often this happens and where in cities the hottest parts are. So I would like to research the characteristics of the urban heat island effect for hot summer nights in more detail based on the fairness platform. Well, that's myself and our research and our contribution in a nutshell. I would like to wrap up with some links to our website, which is unfortunately in Dutch, and a link to the publications. Well, it would be nice to meet you soon.